let's see here. I don't know if we've done any social media.
Yep, we did.
We did some social media.
Yeah, I got.
I don't think I did any social media, but it's whatever. We're gonna record some stuff here. It's been way too long. Though next week I got to go to Brazil,
Yep.
and then my daughter had a baby on Saturday, so I got to go to Mississippi. Basically, we got these two shows. We got 2 more weeks off. Then we got to do it again. But I didn't want to. I just wanted to jump back in here. I picked up my phone because I was going to jump on the socials and just see if there was anything I should retweet, which I'm about to do right now. Okay. A lot has happened since we last spoke with Kronk. I'm going to show off a little bit of what we've got going on at this point. It's really ready for people to start sort of using heavily. So I'm excited about that. And then some of the diagrams that we did for sure need to be sort of redone. Things we were talking about caching and stuff.
Okay.
I want to go through some of that. I thought I'd fix it here. And I've already started writing some blog posts. So we're going to have cronkai.com very soon. I'm going to put the blog posts on there. The one thing I want to stress to everybody is that even though I'm the one working on this thing, and Florin is too, Ardan is more of a sponsor and an owner of this open source project. So there's not going to be a day where you got to turn around and suddenly pay Ardan for something to use it. That's not what we're doing here.
Okay, cool.
All right, but some really exciting enhancements and changes that we've made here. So let me come back over here. One of the things I want to stress is that what Kronk wants to be is your personal engine for running models locally, whether that's you using the SDK or you using the Kronk model server. Now, I found there was a set of models now that are available to us that at least on this machine run pretty well with 128 gig. I want to show the VRAM calculator again as well. And so I've loaded in the catalog. This is the catalog side. I've loaded in the catalog different quantizations of this particular model, right? The higher that Q number, the more accurate this model is going to be. Actually, we can even talk a little bit about these sort of labels here, because the first blog post that I'm writing is literally about model selection and sort of going through what all these labels mean, right? Because once you navigate, I think this is the hardest thing to learn first. It's like, which model should I be using, right? Look at all these options for this Qwen3 coder.
Yeah.
Right? Like, what's going on here? And ideally, you want to run, it depends on your workload. I'm focused on agents. So I'm going to use Klein today. If you want Klein to work properly, then you need the model to behave as accurately as possible. So you need the largest, sort of most accurate model that you can run on that machine.
Okay.
If you're doing just basic text chatting and things like that, you could probably get away with a model that isn't as quote unquote accurate with tool calling and accurate with taking instructions, because you're just having a conversation, which means you can run one of the smaller models and you're going to be fine. It's when that model has to behave, has to take instruction and do it right. This is when you really need to be able to run these sort of larger models. Tool calling for me is like the big sort of stretch where you might get the smaller model to do a tool call when the context window is empty. But once it gets to like 80% full, does it still behave? The answer is no, it doesn't, right? And then I can introduce maybe today the concept of grammars, which really forces the model to behave, but it slows the model down tremendously because on every tokenization cycle that we're doing, we have to sort of force the model to spit out the next token properly. It slows it down, but keeps it in line. So if you had a machine that's fast enough where the slowdown isn't necessarily impeding you, and then you get that level of accuracy, that's a huge win, right?
Yep.
And so you end up with looking at a screen like this with letters like UD and Q and K and M and XL and sort of what does sort of all that mean, right? And the UD value is for the unsloth models. So unsloth, I think, is one of the best organizations on Hugging Face for GGUF models. They'll take the original models that could be, it could be like 500 billion parameter models. God knows how big they are. And they do the work of converting them into GGUF formats of all these different sizes. So we can run them on our machine, or you'd never be able to run these models. Now, obviously, as you're sort of cutting these models down, you're potentially losing accuracy, and you're losing. To me, it's not performance so much as accuracy for what I'm doing with agents. So you'll only see the UD symbols with the models that Unsloth are basically converting for us.
Okay.
And they're doing really interesting things with the different layers of data that are put into this model. So Llama CPP can sort of load that data in very unique and interesting ways, right? Like that's a whole nother data science thing. We don't have to get important. But if you can run a UD labeled Unsloth model, I'd prefer to do that. In fact, I mean, if you look at this list for a second, right? If we were just looking at it sort of at a very novel, like innocent way, like simple way,
Yep.
essentially you can do two things just to start if you're completely blind. The larger the model is, most likely, the more accurate it's going to be, right?
Yep.
Because there's just more data associated with it.
Yep.
And so I like this list in Hugging Face because basically, right, you would need a minimum of 160 gig. And there's always some other overhead on top of that. We can look at the VRAM calculator in a little bit to see that. But I only have 128 gig on this machine. So essentially, way too big.
Yeah.
Plus, it's been my experience that the BF version of these models are really for training, not for using. You might see an F16. That's perfect. That one is going to be your most accurate sort of GGUF version of it. And I've gotten those to work really, really well. Not the BF, but just F. And that basically means it's using the full 16-bit sort of data sets that are there. So never going to run in a million years. Now I got 128 gig of memory. And remember, it's going to be this plus some. So even this is too big. But if I can run a Q8, which is this, we'll talk about what that quantization 8 means.
Yep.
This is usually where you want to be for anything that requires high levels of accuracy. So F16, if you can run it, then you've got the Q8s. Now, on this machine, I'm able to run the Q6 pretty well. That's coming in at like 70 plus gig. And I can handle that machine, and it runs really, really well, right? So for this model, 70 is working really well. There are other models that I'm running at Q8. You might think, well, they must run better. And I'm like, no, this is a more modern model. It's also a different type of model that we can talk about. And so it runs even more efficiently than some of the other models. There's kind of like 3 classes of models that at least I've been working with. Dense, MOE, which is it's called like a mixture of expertise.
Okay.
And then there are these hybrid models. This is a hybrid model. And these hybrid models kind of define how the data is laid out and then how Llama CPP loads these models up into memory. And then how sort of the entire inference process takes place. These are sort of different ways to do it. Llama CPP has support for these. And I'm finding that the hybrid model now is giving me, even at a Q6 level, really great accuracy, where I wouldn't see this sort of accuracy, let's say on an MOE model at Q6.
Gotcha.
All right, but I'm seeing it here in these hybrid models. So I wish I could run this. It's just, I don't have enough memory. Now, if I ever get that M5 with 512, dude, I'm running this shit right here, right? So again, I've never been successful with the BF version. I think this is really designed for training.
Is that what the B stands for? It's
I forgot. I might have it documented. I have it documented down there. But F16 would be. I wish I. Again, it's too big. Okay.
yeah.
So, so the Q is basically they call this. I call it quality.
Okay.
For
Yep.
me, it's the quality level, right? And
Yep.
so, where 1 is the lowest and 8 is the highest
Okay.
quality level.
Yep.
Once you get to F16, that's like pure. So
Mhm.
this is like pure cocaine. Like you don't get to buy that. This has been cut a little bit, but
Okay.
you're still getting high.
Yeah.
This is just going to put you in the hospital because that's like there's very little cocaine in that model there. Okay.
Okay.
It's the quality, man. It's the
Yeah.
quality and how they've basically cut the product.
Yep.
Okay. So, like I said, now you're going to see some other symbols. K, you can see 0 or K.
Uh-huh.
And then you can see basically S, XS for extra small, extra small,
Okay.
small, medium, extra large, and I'm sure you'll see an L here for large.
And that goes for every sort of quantization.
You can, but you see they don't do each and every one, right? So
Yeah.
for the Q8s, they gave you 0 and they gave you a K, XL.
Mm-hmm.
But in these smaller models, they give you more options because since the quality is going down, and we'll talk about what these symbols do, this could help bring some of the quality back
Mm-hmm.
if you can run it, also depending
Okay.
on what you're doing. So you'll see that when the quality is low, you're going to have more options in this, in these, right, in this space.
Yeah.
But as the quality goes up, you don't need as many sort of variants, right? Like these two are like where you'd want to be. If you had this
Mhm.
much memory,
Yeah, if you're running it at that level, then
right.
you want.
And so they did the same thing with the 6, but now when they went to the 5, now they gave you a small and a medium size just because, and we'll talk about what this is doing because maybe this is enough for the workload. Like you really can't use this for an agent.
Mm-hmm.
But my agent's working really well with this Q6. It's amazing, right? Imagine if I could get to the Q8.
Yeah, it would.
Okay.
That would be really.
So this K is basically taking the Q, which gives you a level of quality, and being able to improve it at some level.
Mm.
So you're basically saying we're going to take that Q6 and try to improve that quality a little bit more by using this K-quant thing called XL. So that's why when I'm looking for models, I'm looking first, is there an F16, not a BF, but an F16 at, for me, I really can't go above 70 GB on this model and feel like it's giving me power, right?
Got it. Okay.
So again, you'll know your own machine, but just even if you just wanted to be really sort of ignorant about all the letters, right? For agent stuff, I want to stay here. It's the first time I've done this, but you can see,
Above 6-bit.
right?
Yeah.
And if you just look at the size of the model, that almost tells you enough also that it's going to be better because there's more data. Okay.
Gotcha. Okay.
So this is what the Q numbers essentially mean here, right? It's how many bits of data that we're essentially using inside this model. So the Q8 is that original, although the F16 is like pure, okay?
Mhm.
And then you have either 0 or K. And this is sort of a different strategy for how they sort of shrunk the model down a little bit.
Okay.
All right. So this I already told you, right? Like if you're looking just to see which is going to be the best model,
You
you can
pretty
kind of
much.
almost just look at the size and
Yeah.
and that. So the other thing about this is if we look at this thing here, right? So if we can get to the F16, there's right, it's 0 information loss. We're at the original precision of the model. But you can see here now, we cut this in half by going to a Q8.
Yep.
Okay, and the 0 basically is like the, say, original, or the algorithm, the pure algorithm for this sort of 8-bit quantization, right? So we just cut it in half. And then you have the K variant. So they're considered an improved 8-bit quantization with some better distribution.
Okay, so
So
that would be better
it's
than like
another
the
algorithm
0.
to do this, and it's quote unquote
Better,
it's
whatever
it's doing
standard.
some better distribution or something. So
Yeah.
ideally, this should give you more than this, but you saw that it's a little bit bigger, so you may not be able to use the K because it's just not, it's too big for your hardware, right? But that's information loss. But for the work I'm doing, I need to sort of be here, right?
Because you're doing
I'm
agentic.
doing agent stuff, complex task stuff. So
Yeah.
you can see, the K and the XL, right? And that XL, what it's also allowing us to do is have these larger context windows, which you
Okay.
need for the agent. Though I can't go beyond this 96K context window on this machine with the Q6, because once that context window got to about 80K full, it started to misbehave a little bit. So you always
Okay.
have that sort of problem anyway.
But the context window is determined by the model or by the
It's
machine?
a setting that we get to decide how much data we're willing to be able to put through the model. But the models do have a minimum or maximum context window that they support. So when we find a model, one of the data points in the GGUF will be the max context size.
Yeah.
Can't really go past that. And even if the context size for this model might be 256K, I don't have the memory for that, right?
Gotcha.
Right? Because that's going to affect the size of the model. So when I told you the model plus,
That's the plus.
some of it is how big is the context window? How many slots? I'll show you this that we're going to use. So for a model this big, I can only have one slot, right? If I have another slot, it's going to increase. I'll show you some of this stuff. Now, again, this is your personal engine, so you shouldn't need more than one slot.
Yeah.
Except for cases like, which bums me out, is the Kilo code client. I love the UI, but it always sends like 3 requests at a time. Sucks, because
Yeah.
then those requests have to get queued up and you're not necessarily running as fast as you otherwise would. And if I increase the number of slots to allow that to run in parallel, well, my machine can't handle that.
Okay.
Where client, and I can't control it. I can't tell it just do one at a time
Yeah.
and be more efficient with that. Where Klein will do one at a time and it's efficient with that. I don't
Yeah.
like the UI as much as Kilo.
But trade-off.
You pull
Yeah.
hair, right? Like I'm always it's like, for me, it's always pulling hair. So for what I'm doing, I'm here. But for what other work people are doing, maybe you're just using it to write copy. You're writing content and stuff. You don't need this,
No, it's
right?
overkill.
It's overkill. Like this model, these models, well, this isn't the best model for that anyway, probably, but right, you could probably get away with cutting it even down farther and it producing sort of what you need.
Makes sense.
Yeah. And then if you want to get like really deep technically, right? Like the _0 is the original bit quantization, and then that's a K quant or some whatever that is, right? Like this is beyond my sort of
This is like data science.
This is for data science
Yeah.
people here, right? I don't know if I'm going to keep that in the blog post, but and then the UD, which is just Onsloth stuff, just makes the model more dense with data, I guess.
Ultra dense. Okay.
Okay. And this XL just will allow us to use a larger context window, which is what we want. So you can kind of see this quick chart, right? If we can run F16, not BF, F16, and the size of the model is there, I mean, that's your maximum. Like
yeah,
nothing runs better. Your next level is a Q8 _ K, and then you can choose your size. We can get to the extra large, right? Now the problem is if you use a K, you're going to get the accuracy, but if it's small, you don't have enough context window to do anything real.
Yeah. Okay.
Right?
Gotcha. Yeah.
Right. And then the next level is the original general use, and that can still be really, really accurate, right? But this is the one I'm using. So I'm actually doing complex tasks, right? Even though I'm resource constrained. So
Gotcha.
interesting, right?
So now when we use models, normally like I see us using like the 8-bit when we're going
because a lot of times that's all again, that's all that say Unsloth has provided us, right? So if I come back here for a second, the model that I'd been using prior to finding this next earlier this week has been this one.
Yeah,
Okay.
exactly.
Okay. So if we were to show this one,
Yeah, normally when we're looking, we usually see like 8-bit is where we want to be.
so this has been my model for the agent up until recently. Let me find, am I in the Unsloth? Right.
Unsloth.
So I need 13. This is not the page. Half of this too is also knowing how to navigate this site here. This is not the page I want. This is the wrong one. I've almost memorized all of the pages here, but let's do this just because now I'm wasting time. Here's the web page. Okay, this is what I'm looking for. Now, I've been using this one. Again, that's the KXL largest. You can see it's 36 GB, right? And it's worked pretty damn good up until it's worked really good actually, right? Again, it's not great at tool calling though. So I couldn't really use this model with Kilo, which is pure tool calling, unless I applied this grammar to it. And the grammar was able to force it to always behave with the tool calling. Essentially, this model forgets to add the tool call tag sometimes in a tool call, so I can't parse the tool call out.
Oh, okay.
Right?
Yeah.
This prevents it, but it cuts the model's performance in half. Okay. So when you see Kilo, I was forcing the grammar because if I wanted to use Kilo, I had no choice.
Yeah.
And because Kilo is using up to 3 requests at a time per task, I'd increase the number of slots, which adds more memory to the whole system.
Yep.
This model, so far, I haven't had to apply the grammar to. Actually, I'm using this one to behave, which thank God is good.
Yeah.
But imagine I can't necessarily use this with Kilo because you saw how big it was, right? And now I'm just sort of thrashing memory, right?
Yeah.
So, but we can get more accuracy on some of this stuff. So I'm always looking at this first. Then you can go into files and versions and click on these and get your download links.
Got it.
So now I want the download link for here, copy download link. And this is how we put the catalogs sort of together.
Interesting. Okay.
So this is the model now that I'm using for that. And now this gives everybody a sort of a general sort of idea on sort of, what you're looking for at some level. I don't know where that other page went. Let's clean this off. That shouldn't be there. Sometimes I just got to go back here. That wasn't the one we were just looking at, was it? Whatever it is, it doesn't matter. Yeah, it was the Quen. Anyway, I just come into the catalog and like 9 times out of 10, it just.
Yeah, you have it there already.
I have it here. Okay. So anyway, we were looking at it on the blog post. That's fine.
Yeah.
Okay. So now you're seeing what's sort of happening here. And that's a good start. But this first blog post will break this down a little bit. But just, you want to run the biggest model you can.
Yeah.
If you need the highest level of accuracy like we do. So I'm going to run the make cronk server, and then I have a build just so it rebuilds the BUI. When people download this, they wouldn't use the make commands. They'll just have the CLI tool and they can do a cronk server start.
Gotcha.
Okay, so now the model server's running. This is the cool part here. Let's go into the other project. So we're going to be using I called it Klein, mainly for my brain right now, that basically says I just need one slot to process everything sequentially. And since client only sends one request at a time, we're fine. I set 2 slots here because we need to be able to have some things run a little bit in parallel, right? But if you go into the BUI, going the wrong way here. Once the model server's up, you can go into the website that we have there. It's pretty cool. And under apps, we've got the VRAM calculator. So let's go back to that model that we're using here, the 6, right? I can just give it, I think I can give it this folder. And it should, we'll try that out. I think I can give it, yeah, resolve main. Oh, actually for split, this is a split model. So let's talk about what split models are. Let's go back to this for a second. So you can see that once we get to 5, there isn't a file here. There's a folder.
Yeah.
And you can see here that this is what's called split files. So the model is split into 3 separate sort of files. Now, what's cool about this is we can load all 3 files up at once, which is what I'm doing.
Yep.
But if you had multiple GPUs and hardware, you could load this up in separate cards.
Oh, okay.
There's special drivers and there's support, and that's why we have a cluster coming on Friday to play with this.
Oh, nice.
But we're gonna, yeah, we have 2 Mac Studios coming,
Cool.
each with 128 gig on them, and the idea is to cluster those so Llama CPP thinks there's right that we can load the models across those cards, and we're gonna learn make sure that we have all the support for the clustering.
Yeah.
Now again, I really care more about you and your laptop than that, but it would be nice to have that sort of support. That cost us $8,000, right? These laptops are about 10. So I want to stay within that $10,000 less range on chronic kicking ass, and so we'll need that. So that's a split model right there. So when I run the VM calculator, I got to add all 3 of these up. I can't just give it one individual file.
Yeah.
Now context window. So let's start with like standard 8K content, which is way too small for that.
Yep.
And then let's say we use F16, which is 2 bytes basically for every data point in the KV cache. This is going to give us also our most accuracy, right? If we don't have to cut the KV cache data in half, then the model's working with full sort of numbers.
Yeah, it has like full resolution almost.
Yeah, think of it that way. So let's say with 1 slot, this model, this Q6, which if we go back and look at the Q6, this was what, 50? Let's say it's 20, 70, 76 minus a couple. So say it's like 74, right? But even that, look what this is saying to us. I wonder if that's correct. I would think that we would need more than 64 when the size of this calculator might be wrong.
It's 18, so it is, yeah, because it's like 50 and then 10, so 60.
So let's do something.
It's really like 69, 70.
Yeah, I would think this is larger. So maybe we've got a bug, which we can use AMP to sort of figure that out. But you can see something here before we try to fix that bug. Let's say we use what I'm using, which is a 96K context window.
Yep.
Okay. So you can see now that that number sort of jumps up. Now, if I didn't have enough memory, I could maybe run it with less in the KV cache and the number will go down. But I'm looking for like as much accuracy as possible. Now, like, let's say I wanted to use this model now with Kilo, right? Now I need 2. So the numbers just continue to go up because now I need memory for a second slot. If I gave Kilo all 3 slots, which is really what it would run at best, now I need 90. But I don't know if this is a bug or not. So why don't we do the following here? Let's just check something out here. Okay, I am using this model with the VRAM calculator in the BUI.
This is cool. I haven't seen you use it this way before.
Yeah, I wanted to use the other two agents in the CLI too, but they're not as sophisticated as their plugin versions. And since the plugin for AMP is going away, I just sort of had to be here. But it has context. If you're in that folder, it can read VS Code and know it's open and shit. So.
Oh, okay.
Okay. This is a 3-split model with the following sizes. So what do we have here? We had 5.94, we had 49.9, and we had 18.7. I probably should put GB next to every one of these. Okay. When I run the calculator with, now what settings are we using here? With a 96K context window, a KB cache type of F16 and 1 slot, we get a grand VRAM total of 72.88 GB. 72, right? 72.88 GB. The 3 models are larger than that, right? Let's just do the math again. Just to check, because, you know, I'm dyslexic with numbers and maybe I'm just completely clueless here. So 5.94 plus
49.9. The other one I forgot. I think it was 18. Yeah.
So that's 74, right? Which is good. 74.54. So it's larger than the 3. No, not large, right? The 3 models are larger. Shit, I erased that number. What was it? 74 GB.
Yep.
So I am confused with the total since I thought the total would need to be at least as large as the model itself. And I know there's a small amount of GGUF data in there, but let's see what it says. I would have expected that number to be larger, right? Oh, I should have pointed it to the VRAM calculator. The VRAM calculator exists.
I was gonna ask how you were doing that. If you have like
here.
some.
Yeah, we got a code here.
If you have like a formula going on. So AMP is taking away their VS Code extension?
Everybody's basically going to eventually do that, and everything will just be CLI tools. Because then you can iterate faster if you only have to worry about one client as opposed to like several. Like I understand where they're all going. And since everything's going towards the OpenClaw agent shit anyway, they need all those tools need CLI. They don't need VS Code plugins. So if you're an engineering team and you got to just want to move faster, it's better to be on the CLI. Focus on your CLI being great, because all the tools that are going to use your stuff will be running from the terminal anyway, or can at least shell out and run it from a terminal. You can't run a VS Code plugin.
That makes sense.
While that's doing its thing, I do have a learn more here, which sort of goes through the calculator and sort of how it works. And so like a real world example with this model is this formula here.
Oh, okay. So that's sort of the math.
Like that's the math. If you wanted to like walk through it a little bit. So that's why I'm kind of curious if we're doing the math wrong. We're not adding necessarily all the models up or something. Now, when AMP takes this long, either I have not gave it enough information or it's just, okay, so, oh, is this MB?
It is MB.
Oh, that was MB, not GB.
The 5.
Oh, even the guy online told me that. So, okay. I see.
Is larger than the model.
Yeah, so when we look at the model size, okay, that was my bad. I just wasted tokens for no reason. This is MB.
Yeah.
So it's really, if we did the math again, 50, 70 minus, well, even that is 50 and 20 is 70, right?
Mm-hmm.
So even there, we still said 63 GB. So even that is still small, right? So let me see here. The BUI's format function uses, but labels the result. Shows files in GB, so. Well, I just noticed one of the files are actually GB. GIB. But
68.6,
yeah, and we're at 63.
which is about 63.9.
In the calculator, the model
So
size is.
GIB and then GB.
I switched everything to GB.
Oh, okay, that's what it's saying. It's 63.9 GIB.
GIB is another way, but everybody
Yeah.
uses just GB, so I stopped.
Yeah.
I stopped with the I because everybody was asking me, why'd you put I there? I'm like, be interesting to see how companies or products like IntelliJ will adapt to the prevalence of CLI only tooling driving development. Yeah, I don't think they're going to have a choice to it's just the way the world's going. But yeah, it's an interesting question. So 68, the BI shows 63, which is 63 GIB based. Well, I'm still confused about the 68.6 GB versus the 63.888 GB. Are we, how are we getting the actual size of each split? Let's see here. It could be that Hugging Face is just labeled everything fairly wrong. And then when we read the actual, right, this could be just a label. And then when we actually bring it down, it's a little different.
Okay, yeah. Which makes it look smaller than what Hugging Face shows.
So what are you telling me here? It's just expressed in different bases. Different bases.
Because GB is a base of 1000 and GIB is a base of 1024.
But that's saying GB. It's not saying GIB.
Yeah.
Okay. We need to use GB in Cronk.
BUI format bytes. Oh, but
For
it's saying in Hugging Face it is GB on the website, and then in format bytes
Let's fix
you're
format
using.
bytes. I didn't
Yeah.
think there was a difference between GB and labeling something GIB. That's weird. And I thought everything would be in 1024. Let's see what happens
Yeah.
if we do that.
So it's saying the base is 1,000 now. Okay.
That's confusing to me. This is like I need Ian to explain this one to me. I don't know why I and non-I is in a 1020. Let's just see what this looks like. Because I've been doing everything in.
Oh, you say it a gib. I'm having trouble pronouncing it. A
Gigabyte versus
gigabyte.
gigabyte.
A gigabyte
Dude, I
versus
had
a
no
gigabyte.
idea, bro. That difference between. I honestly thought these were the same thing.
1 GIB is roughly 7% larger than 1 GB.
Dude, I thought everything was done in 1024. I wonder if how much code is just wrong.
GIB is the binary method, which is how computers measure it.
I know, but
Wow.
I wonder if our download numbers are wrong too then. Let me see something here.
Interesting.
Can you check the download code where we show the sort of download per second numbers? Are we calculating that wrong as well? I don't know, dude. This is mind blowing to me.
Yeah, this is pretty cool. This little chart here.
This is mind blowing to me. Like in all my years. Let's do this again. How can I just be learning this now? 8, 16, 1. Now the model size is 68 point. That's what we calculated, isn't it? And we did all the math.
Looks.
I think that's right. What it's calculated. Dude, this is mind blowing to me. Like honestly, mind blowing to me.
68.6. Yeah.
68.6?
Yeah.
Okay. So this is now accurate.
68.6. And
what did it say about the download code here?
Oh. It's doing a bunch of stuff. Same issue. So everything was calculated 1024 for GIB, but
That's
labeled.
my fault. I didn't know about this. Like I honestly didn't know about this. This is like it's hurting my brain right now. Thank God for AMP. Oh my God, bro. All right.
So everything was like 7% off, basically.
Yeah. That's wild.
Interesting.
So now, since I'm going to use a 96K context window, right? This is how I'm going to run it. Now I have 128 gig. I can't use all 128. I mean, we need some of that memory. But I think that if I stay within this like 80 GB number, I'm usually pretty good.
Like this is what these are pretty much the settings you're running.
Yes.
The F16.
Yeah.
96K.
I wanted to run this, which one could argue I could pull off, but I really saw this model misbehaving when it got to certain. So there's no reason to eat up more memory when it's just going to misbehave at that level anyway.
Exactly.
Okay.
Okay.
So,
cool.
Dude, this is mind blowing to me.
I learned some math today. That was.
That's mind blowing to me. It's gonna like bother me for the rest of the day. I didn't realize these two labels meant two separate things. And you know, the Go team uses the I label in their tooling. So I just thought they were just being cute. I didn't think they were. Gosh, I'm freaking mind blown.
I've seen it with the eye before, but I just never like paid attention to what the difference was.
I didn't know. I thought it was just another way of labeling it. Okay, so we've now talked about the VRAM calculator. Okay, sweet. So let's do the following now. I'm going to use Klein in here, and I'll just show you some interesting things that we can now do. Let's just select them. So anytime I'm making changes to the engine, I always run this first sort of test to see how fast this happens. Well, first I'll just say, hello model, tell me when you are ready. And I just do that because this has to get loaded. You can see it's starting to load the first split.
Mm-hmm. Okay.
See what Ian is saying?
Yeah, I see that.
I honestly, after all these years, didn't realize that these were two different. And I do everything in 1024 calculations because like everything with memory is 96K, 96 times 1024.
Yeah, exactly.
So I didn't think on like this stuff on disk and stuff would use a different. So it's every 1,000, not every 1024. I mean, that makes sense.
Yeah.
It's every 1,000, not every 1024, because we're not dealing with memory. We're dealing with like data.
Oh, okay. So that's the difference.
Yeah.
So like if you're dealing like let's say with RAM,
Then we're dealing in the
it would be
1024.
then
Yeah,
you're dealing in the
the
1020.
MIB, the GIBs.
Okay.
But if we're dealing with like data going over a wire or on disk, then you want to deal with GIB.
Then you want to deal with GB.
GB or MB because then it's on a it's cut by 1,000. Yeah,
That's
I'm
cool.
just learning that for like I never made that now I'm gonna tell Florin this later and he's gonna go, of course. What do you
He's gonna be like, what do you mean?
Okay, so the model's now ready. So we start a new task. So this is always my first question. Watch how fast this is going. How many lines of Go code are in this project? Let me run a couple of these and then we're going to redo some of our diagrams to show how we're getting this level of sort of performance. Yeah, you knocked that out. Okay, user wants to know how many lines of Go code. It's cranking out some stuff right now.
Thinking.
This is with the 6 model. Now, what's nice about Klein is it doesn't really use the traditional tool calling. It has the model do tool calls inside the context window, which has really made it very stable. So, dude, that's pretty fast.
I mean, it looks great. It looks normal to me.
Right?
Like
amazing, right? The only thing I hate about Klein is in this sort of scenario now where it's done, you can't ask follow-up questions to this thread. You have to start a new one. Sometimes it puts you in a position where you can ask follow-up questions, which is nice.
Oh, like the model will say, oh, is there anything else? It will
come back and say something, and then you can do that. That's, to me, the only bummer. So if I ask the question again, what will be sent to the model is essentially like this output, and it will be basically told you're done, move on, right? Okay, but that's pretty good, right? We agree that's fairly reasonable ask right there.
Yeah.
One other thing I need to make sure is we'll talk about this too. Okay. So the next thing I always do, and these are tests I run if I touch anything. All right, new task. Give me a summary of this code file. Now these are simple one back forth shots, so the incremental message caching optimizations aren't necessarily doing a lot just yet, but I'll show you something that is kind of cool. Like, right, we're just sort of building up what we can do here.
Yeah.
So it's processing that. Good.
Okay, now I
Right.
hear your fan. I was gonna say I haven't heard your
Yeah,
fan kick
so
on.
I have a program here I should run. Should show everybody. Why is it not starting?
I see it up there in the like bar.
Oh, that's right.
Oh.
Hopefully nobody hears the fan running. Ian, if you hear the fan running, let me know. But if I run this at 45 RPMs,
Mm-hmm.
things will work better.
Oh, so you just have like a manual
This
override?
program is cool. You can pay for it. I haven't paid for it yet, but if you pay for it, then you can do more things with it. But yes, I can control the fan at will. So when I'm running big tests or I'm doing things,
And it helps
oh my
keep.
God, dude, yeah. If these chips stay cool, they run better. Because if they start to overheat, the clock speeds have to come down.
Yeah. I wonder
Or
why they didn't just do it like
Mac doesn't
faster
give
from
this to you. I don't know.
yeah, or
Well, this lets you do a whole bunch of things if you pay for it. So like Florin paid for this.
wow, that's cool.
Um,
I'm gonna try.
but right now I just got the free version. So if I reboot and things like that, I got to reset some stuff. But okay, so look at that. That was pretty good, right? Now let's have it do something a little bit more interesting. Um, so it will make I can get it to make small code changes because I just have a small sort of context window, right?
Mm-hmm.
But like one of the things that I did is I've cleaned out all that code up, but what would be another good, okay, like let's do this here.
Maybe just having it do like a code review or
Yeah,
something.
let's have it do a code review. Let's see what changes we made. Okay, let's do that. Okay, so I asked my other agent, don't be jealous, to make a code
Don't be
change
jealous.
to this file because we were using GIB instead of GB. Can you verify the changes that were made are correct? So these are things like I can do on the plane now, and it's running at a fairly decent performance level. We're not getting like massive TPS. I'm getting 27,
But you're still able to
but
use it
it's the
on the plane.
accuracy of it. So
Mhm.
even though my other coding model runs at like 50 TPS,
Yeah.
this model is more efficient at what it's being at figuring out what to do, so it runs faster,
Oh, okay.
right?
Like the turtle and the
Yeah,
rabbit.
yeah. And so even though the TPS is smaller, it's more efficient and smarter, and so it gets to the point faster.
Yeah.
So here, user wants me to verify code change. But remember, it's the model that drives all this stuff, right? The
Mhm.
tooling is there to help coordinate. But if your model's not behaving, it doesn't matter what the tool can do.
Yeah. Okay.
But this is still, we're going to talk about now. If I didn't run this with the IMC optimization, which I'll talk about in a second, we wouldn't even be getting this far this fast. And this is a fairly decent, review here.
Yeah, it's a couple different
And you
files.
got to just stay within this context window when you're doing things anyway. So it kind of makes me have to be a little more, as opposed to what I just did with AMP, right? Just go from,
Yeah, just do this.
but
It's
still,
more.
dude, look at this thing fucking cranking on the machine.
Well, it's cool to me that it's just all local. Like it's not using any sort of internet. Like
For this, it's not.
that part's
It's
nice.
even going through the Git log to see. Now, again, the model's making these decisions, right? So imagine I could get to the Q8 model. It will even be more efficient.
I mean, I can imagine like if you got like for example, how you're going to be clustering the two Mac Studios.
Yeah, now I can get to a model. Now I can definitely run the Q8 KXL, but
Not having to pay
I want to
for
be able to
tokens.
sit on the airplane on this trip to Brazil next week and have some agent support. So look at that. This is all running on my Mac with the Q6 KXL model, this next model, which is it's fairly a new model. Now, I'm not going to let it, oh, shoot. I told it to just plan, so hopefully it didn't make any changes. So it thinks that
Oh,
this was incorrect, right?
1024.
So this is interesting, right? I don't know enough, right? So let's do the following.
Verify it with this one. Oh, I don't know.
I just asked Klein to review your changes.
And this is interesting because this is the same thing I was doing with Claude and using like the cursor composer model. I was messing with this sort of same scenario the other day of filtering each other.
Oh, shit. To this MB. It's telling me you didn't do things correctly. Please verify. Now I expect that 10,000%, right?
Yep.
You see what happened,
Okay. It wasn't synced.
right? So, and now what sucks is I can't do a follow-up no matter what here. It just sucks. So
But why can't you do a fault? Like it doesn't maintain the context
I don't know.
between.
It's just the way its system prompt works or something, right?
Huh.
So AMP said you did not review the latest code changes. So review again with current. See, watch what happens if I do this. It's just going to come back and say task complete. This is for me, the biggest bummer with Klein. Let me see. See, it didn't, it ignored me,
Yeah.
right? It ignored me. And then they have this concept of called new task,
Okay.
right? Which is supposed to use this context, apparently, but it doesn't work either. So to me, this is like the big bummer on Klein. And I've tried to go on their Discord and get help, but nobody wants to help me. So, but it's the best local agent I've seen so far that can run single requests. But this to me is the biggest bummer that I
Yeah.
can't stay within this thread. Once it's been, you see? Oh my God, did it make a change?
I think it did. Oh boy.
I'm in plan mode. It shouldn't be making changes.
Probably just Control F that.
No, I didn't
Oh.
save it before I did that. So I'll have to ask AMP if anything bad happened. I don't think they made any change.
I think it was just that log.
Oh no, yeah, the file has been updated and the change is now correct. Oh,
But he didn't.
so it took a follow-up question. When I'm in plan mode, I've been, okay, so now it worked, right? But you can see that the model went, this is the problem with the smaller models, right? The model went into the history to see the change and use that to make the calculation. And without the other, so We're getting there though.
Yeah.
Look, I mean, look at all the work that it's doing, even within the small
I'm
context.
yeah, this is
Now, here's the other thing that I added. I turned Kronk now has an MCP
oh,
service.
okay.
It's a separate service, but Kronk will load it up for you automagically. And I'm using the Brave API. So we implement our own MCP using the Brave API. And so now what that will do, I just had to connect it. But what that will do now is I can ask something like, use the Kronk MCP service and look up Ardan Labs and give me a summary of the company.
It's insane how far this has come from when we first sort of looked at it.
Yeah, no, right. So now what should happen, the only bummer here is I have to tell it usually to use the MCP service, or it will use some of its own tools. But if I'm doing some research, like for the blog post, I was just using this. I wasn't using AMP. And I was like asking it to do these lookups for me and find me stuff. And
Which is nice because that's saving you
yeah,
tokens,
it's
you
all
know?
free, right?
So,
So here, now you see it's doing the web search against basically Kronk's MCP service.
oh, okay, I see it up there. I saw it.
And now it just gave me. So here's the cool part about what I did. All these agents, they have a whole marketplace of MCP services.
Okay.
But most of them are written in Node.
Mm-hmm.
So when you tell them to install it, now they're installing it somewhere on your local machine. Node stuff. You don't have Node installed already. You can't. Like, I don't want to do that. I want people to be able to just download Kronk and run it.
And go. Yep.
That's it right there. Because I'm not using an MCP service per se. I'm using their API, and I'm the one fronting the MCP service.
Okay, I see.
So if somebody comes to me and says, Bill, I really want to use this API, then given a key, like I have my own key here, we can extend this MCP service for all the different tools that people want. So you don't have to worry about installing anything. You just need to set your key.
That's nice.
When you start Kronk, you set your key. And then look at that.
No, that's perfect.
Yeah. And here's all the research that it, right? All the web calls that it did. And we're not
Very cool.
stealing, we're not screen scraping, we're like legitimately using somebody's service. I pay $5 for 1,000 searches. Like, it's nothing.
Yep.
Okay, so
Very cool.
we have some.
Brave API.
Okay, I'm gonna turn my fan off now. Nobody can hear it, but I can hear it now. Go back to auto. So we've got some code changes now that and let's kill this for a second. We've got, and this is the work we did for the MIB stuff, right?
Mm-hmm.
All right, so.
I think we should verify though that it didn't actually make a change.
No, it did. It was in plan mode anyway. And it said
okay.
now it was correct.
Okay.
That's why I stay in the plan mode there. Okay, let's just push that. Oh, I was in main, huh? Okay, I didn't push it yet, so that's good. I never do that. How is that even possible? Did I? Oh, because I tried to, I thought Florin had made a change and he didn't. Okay, let me see if I can push this from here. I don't want to push that in main. That would be. Let me try this again. Yeah. Wi-Fi setup instructions. All right, let's just do this then. Should be okay. Whatever, I'll fix whatever I did there. Okay. Our changes are now here. Yep. We're good.
Cool.
Okay. So just giving you a small tour of that. Plus, there's all these new apps now that we have in here too. Cron. I always just use build just to make sure I got the latest UI. I think the Go community is still small, and you're the top Go SWE. I don't know if he's talking about that. I couldn't get anybody at Klein to help. But. So we've got a fully. Oh, dude, look what we can do now on the chat side.
Oh.
Can play with all these settings, and
Whoa.
if you're using a model that's in the catalog, that will come in. You can use that.
And I'm assuming Florin knows what all of these do. Like
luckily I do
drive.
too.
You do?
Yeah. I'm gonna have blog posts that go through all
Oh,
these
okay,
things.
yeah, because I don't know what
But
dry and
no. Well, dry is about
like,
do not repeat yourself.
yeah.
But these are the defaults, so you shouldn't have to play with most of these numbers. That's why we put these sort of on top. These are the ones you'll probably play with, and that's why also in the catalog. In the catalog, we have sampling parameters that we know are like the best, at least on average. You still might have to tweak it for your machine. But the things that we feel like users shouldn't have to worry about beyond the defaults, we put in the catalog.
Gotcha.
That's another reason to have the catalog. So, so now, we can just start playing with this model, right? Let it load first.
Very cool. Yeah, I've never seen these like XTC probability log props.
Write a small hello world program in Rust. And you can copy each one of these code lines out to,
Nice.
and you have your TPS here, right? So, and we did work to make sure all the emojis are working and stuff. So we also now have history. So if I clear this, it will say, save this chat to history before clearing. Okay. Now if you hit history,
oh,
you have it here.
And it gave you a little animation and everything. Okay.
And there it is back.
Very cool. And now you can actually like go and continue the conversation and it'll have the context.
Yeah, pretty cool, right?
Nice.
And I think I showed you, we support the images and all that too, if you're playing with one of the vision models. Have you seen that?
I didn't see that. No.
Oh, so I just got this vision model working for Ed. This is a new one for us. So we can do something like, that's a deer. All right. Is the deer in this picture a doe or a buck?
No.
We'll bring up the picture. I just got to load the model, but let me bring up the picture. I pulled that out of here, right?
Ian mentioned that the header says apps, not chat.
The header says, oh, shoot. Thanks, Ian. We'll have to fix that. So based on the visual evidence, this is a doe.
Correct.
Which I think is correct. There's a doe here.
It's just too
it's
fuzzy
too
on that
there.
other one. But it looks like it.
Yeah. Pretty cool though.
That is very cool.
Yeah, we got to fix that, dude. Thank you for that. I've never seen that. I didn't realize we anyway, so that's what Ed is working on now using the SDK.
Very cool.
Sending the deer pictures in and saying, is it a doe? Is it a buck? Is it, what's going on? But that's pretty cool, huh?
That is pretty cool.
So the app will do that. Again, this is all going through Kronk, right?
Yep.
And so now you can build your own SDKs say with that model or any other model and work on that. And then this
Very
is
cool.
what Florin's been working on. This
Whoa.
thing, I told him he needs a manual for this. So
Yeah.
if I just start in manual mode, right? Let's say I just decided I want to start seeing what my Q6 UD Klein model does in IMC mode, which I still have to talk to you about, right?
Mm-hmm.
Use the this built-in template and whatever. So I can say, let's just verify that like basic chat works, right? So using flash attention and one slot, these are all coming from the catalog. All right, so sessions loaded. Now I can do a basic. I can now just come in here and just very quickly test a model that we've downloaded. It doesn't have to be in the catalog, right? So that's pretty good. That worked. Let's see if tool calling works. We're going to give it that,
Okay.
right? We're going to give it this tool in the weather.
Oh, okay. So you already defined it there.
Yeah, and you can change it. So that worked.
Okay.
It said Boston. And then we can validate like the prompt is rendering right. Okay, not bad, right? So some basic tests here. Then we can go into an automated mode. And then we can do something like oh, I gotta unload the current session. Sorry, unload the session. So let's say I wanted to figure out what the best configuration is for this model at a model level, right? Or the sampling is even more interesting. Like I want to go through all these iterations. So a temperature iteration from there, there to there, like all these different things. Because I want to know what temperature, top P, what all these should be.
Mm-hmm.
Okay. And the same thing at the model level. I want to know, does this model work best when I'm using an N batch of, let's say, these three sizes versus an NU batch of the same three sizes? And maybe I only care about a context window of 128K, right? And I only care about one slot. And I only care about these two, and we're going to use flash attention. And I only care about IMC. So I want to know essentially which N batch and NU batch gives me the best performance, let's say. So I set this up for this new model. I say run automated tests. It creates a grid. And now it starts trying all these different.
This is so cool.
And if I want to like see this one first, which I do, I want to move this.
Oh, you can move it up and
I did that, yeah, because I want to see, like, these are always like really what I care about almost. I care about this, and you batch. Like these are the most interesting ones to me. Let's just say.
does that change, or is that like is that something that needs to be dynamic, like drag and drop?
No, this. No, I'm just changing the order because
Yeah.
once it finishes this, like I don't even care about this one right now. I mean, I could have not included it in the set, but
Gotcha. Okay.
right. But let's just say these are the ones I'm super interested in. And
This
then
is really
I can
cool.
totally tell it like I don't care anyway, right?
And how is it sort of doing this like estimation there? Like, is there a set?
He's looking at how long these things are taken and then he's adjusting the estimate. So I'm kind of
Okay.
calculating it on the fly.
Gotcha. So there is like a set estimate based on.
Yeah. So we would normally run either like 512, 2048 or 2048, 2048. Even this test, I mean, we really wouldn't do that. But so we got to load the model, run a bunch of tests, unload it, and then reload it with the new settings, right?
Okay.
But by the time this is done, I'm going to know for this machine, right? And the workloads that we're putting through it, which are like real workloads that we've created from other tasks that we've done.
Okay.
Like, what settings should I be using for this model on this machine?
How does it
And here's the
like,
cool part. You see how it says it's testing there?
yeah, like what is it actually testing? Like how to,
Oh, dude, it's running a bunch of, look
like what is the, I guess, I don't know, the test.
here. So here's an in message.
There's a background indescribable what
This is
happened.
just the first 400 bytes of it, but so we're giving it real prompts that
Yeah.
we have, right? So there's
Okay.
a system prompt and a
And it's multiple prompts.
yeah. Well, you have to
Okay.
fill the context window up. So in some of these tests, you want to see what happens when a context window is empty and then when it gets full,
Mm,
right? So
okay.
like this is the one we're running now, but we're also running it against all these different sizes. So if I were to find, that's the final parameters, but we're playing with model config right now. So
Okay, and
that's what we returned
that's the output.
in one case. Yeah. So I have what's called insecure logging on, which gives me some of the input and some of the output up to so many bytes.
Got it.
And you can see the sampling parameters we're using here. So
That is so cool.
yeah, these tests take a long time, but you would start this and then walk away,
And it's doing
go
it
do
for
your
you.
day, and then when all this is done, then you come back and I used a big model here. If I had used one of the smaller models, this would have been.
And you're looking more for like performance here than like actual answer
So
quality.
I've had this conversation with Florin a bunch of times, right? Like I care about duration
Yeah.
more than I care about tokens per second because I don't care if the model runs slower TPS if it finishes the task faster. Like I'm seeing with the Q6 next model over the Q8 other coder model,
Oh,
right?
okay. So they're not like directly related because it can have more TPS but be going in circles.
Yeah,
Yeah.
right.
Okay, I
The
see.
the the time to first token is always interesting because depending on how that's like getting to the starting
That's
line.
like startup, yeah.
So if you don't get to the starting line, you can't do anything.
Yeah.
So I don't mind looking at TT, time to first token. And this is like when the context window's at empty at 20%, at 50%, at 80%. And so for me and the stuff that I'm doing,
Hmm.
I sort of care about this particular number here. I always want to know how fast the task took because that to me is the real,
Gotcha.
that's the real. But he's going through and increasing the size of. But what's also nice is now I can take these logs and feed them to AMP, right? And ask it. So let's just do that, right?
Okay, because I was gonna ask, how do you verify like that a task is completed
Well,
or
I know
correct?
he knows that on his back end, but
Got it.
if I look, let's just pay the tokens. I'm gonna take all this.
Ooh.
Okay. We are running extensive tests against a hybrid model using IMC. Can you verify these logs that everything is working as expected? Now, when I do a lot of this engine work,
Mm-hmm.
I make sure the logs have everything it needs for the agent to look at this stuff. So as part of my thing, I'm always like, add everything we need so we can review these logs later.
So you're almost logging for the agent.
I'm logging for the agent to be able to review it
That's cool.
for sure. I can, and by doing that, I'm also able to look at these logs, right?
Yeah.
But so let's see that.
It's kind of a cool way
Now
to
this is
approach.
running, right? He's doing a lot of stuff on this model, but that's fine. This is the part of the engineer now. It's like if you're not going to write code anymore, per se, then you need to for sure do all of these things to validate. You need to have the tooling do code reviewing, and you need to run benchmarks, and you need to run profiles, and you need to send the profiles in. They need to be analyzed by somebody or something just to make sure that everything is. I even do idiomatic reviews with the agent,
Okay.
right? There's no if else clauses in this code. I clean all that up
Yep.
anyway, but I spend the majority of my time doing that, and then running all the Go tools and the community level tools that are out there as well. So I think like we're now at a point here, you can see how much we're waiting for a response to come back.
Yep.
And you can see there's 107,000 tokens,
Oh, okay. And that's the
60, almost 67,000 in cache.
yeah.
So this test is like, really, I shouldn't have used such a big context window because he's going to try to push it. And I remember this model really shouldn't go above 96.
96. Yep. Okay.
I'm going to stop this for a second. I should have used a much smaller context window like that, right? So to me, this to me is like a real, though that context window was too small. Let's just wait for this to calm down, and we'll run it again here so we can see. Exactly, I've done that. So it can do what it's doing now, Ian, just review these logs and validate that the batch engine's working, the caching system's working, and that we're not seeing any errors in here, and that numbers are increasing, right? So the cache tokens increase as expected, or we evict as we expected.
Very
Okay,
cool.
so we just connected, so we've got that. So let's run this again, but we'll just run it for this. We should see it finish. That context window was too big for this model.
So now with the smaller context window, it should be
See, now what's bummer to me is I don't even want to run this. It could be with all this stuff going on.
There's a lot happening.
There's a lot happening. We're like hosey hosed. I don't even know if people see us anymore, bro.
Nope.
Are we back?
I should see it pop in a second.
I think Chrome now.
Yeah, there it is. We're back.
All right, I killed Chrome. So Chrome took a massive crash.
Oh
Okay,
boy.
but look at this. Everything is working as expected. Here's a breakdown. So hybrid model IMC, which we still haven't talked about yet, but
Okay, they see us. Okay, cool.
yeah, Chrome just Chrome wasn't happy.
We reached the edge of the hardware.
Something. Ed's always telling me to get rid of Chrome. But look, so by looking at those, we know that this is working, right? The non-deterministic hybrid build path is very expensive. Hold on a second. Was this model experiencing we're going to talk about what this is, deterministic template? Okay. That's what I thought. Oh, yeah, that would make sense. Okay, that's fine. So, oh yeah, just totally crashed. Chrome did not. Once I killed Chrome, everything came back. Everything came back.
My Chrome is a mess. It takes up a lot of memory.
Yeah, I don't know. I just have a hard time switching off of it.
Every
What
time.
is paragraph 4.9? You talking about this, Ian? Yeah, I wanted to get into some of this stuff here, sort of next. But okay, so I'm not going to try to run that again with everything else that we're doing, but you
Yep.
can see how cool the model playground is
Yeah,
to kind of find the best settings here.
that is awesome.
Now, one thing I did want to do on the show is clean up some of the diagrams we had for the message caching stuff that we talked about in the batch processing.
Yep.
Stuff has gotten fairly complex. We can talk about it at a high level, but 4.9, which I'm assuming this is what Ian is talking about.
The agent mentioned it. Where's 4.9? Oh, I saw it. Oh, I saw it up. There it is. Per manual.
Where?
Right here. Per manual 4.9.
Hybrid constraints enforced.
Where'd get F6?
Huh. That is interesting, dude.
Per manual. It has context of your docs, right?
Yeah, I
Huh?
tell it to point it out there. Why would we have to disable flash attention with a KV? Okay. Let's read 4.9 for a second. I didn't even see that. Because that semantic I don't understand. We're going to have to ask. Cronk supports the 3 architectures. We know about these. Dense, MOE, and he said it's there again on 4.9. I don't know. Let's
I
just
guess
read
further
this
down.
because this one doesn't make sense to me.
Okay.
Yeah, there it is. Let's read 4.9 because I wanted to talk about some of this anyway. So we have 3 different model types that affect really how batch processing works.
Okay.
Got dense, which is the sort of standard. So an example of one of the dense models. If we look in here for a second. So not templates. An example of a dense model is just so you have something in your brain there.
Mm-hmm.
That so this model here is considered like a dense model. At least we treat it as that. Then you've got an MOE model, which is the one that I was using, like this. This is an MOE model, a mixture of experts.
Okay.
Okay. And it just really means how the data is formatted, structured, and then processed, right, in different ways.
Got it.
Then you have these hybrid models, which is the one I'm using for my agent. That's that new Coder Next one.
Okay.
Okay. Architecture, attention plus recurrent, some of this stuff. And then there's state management, which is related to how we're managing processing all this stuff.
Yep.
And this has to do with caching and things like that. So partial range delete means we're going to keep as much of that as possible. And then if something changes somehow, we're going to try to keep as much as we can up until that change instead of wiping out the entire cache.
Got it.
So
Okay.
when you hear me talk about is the template deterministic or not,
Mm-hmm.
and I wanted to clean some of this sort of up here. I don't remember that diagram here. Some of this stuff has to be redone because I don't think any of this, like we don't have sequential inference anymore. We only have parallel inference now. And at a high level, this is still very much correct in terms of the diagram at a high level, right?
Mm-hmm.
Like what's happening. We can bring this in. But this stuff has gotten super complex now because when we talk about state management, we talked about the first message coming in. Maybe there's a system prompt and a user.
Yep.
So we store that in KV cache. In fact, we now assign again, I want this system to be your personal engine. So even though you could have multiple people using the model server at the same time. To get the most efficiency out of it, the idea is that you're the only one using it.
Okay.
Okay. So what we now do is essentially when you turn IMC on, which is the incremental message caching, you specify that end sequence value. There's a most important value in model configuration. And by default, it's set to 1. So if that is set to 1, then what you can imagine is that we create a slot. The slot is where all processing takes place for a request.
Hmm. Okay.
Right?
Yep.
So we give you slot 0. And basically what we're saying now is every request comes in will be processed through slot 0. And we maintain our KV cache for this slot. And now what happens is, it's probably better to do it this way. Show the slot small and the KV cache large. So now if you play out this scenario that you see in front of you here,
Mm-hmm.
let me just tighten this up a little bit. So when that first message comes in, okay, let's say these two messages come in, right? A request comes in here. Call it request 1. And it's got that user and system. So we're going to process this request 1 now in slot 0. But before we do that, what we're going to do is we're going to take that data that came in, that input data, okay?
Mm-hmm.
After it's all processed, just say, we'll just call it the input data. It's going to go into the KV cache. And then we're going to process this request against this data, right? There's going to be some output that comes out of it. We will just show that this way, right? Out of the slot, there's going to be some output, and we're done. Now, when the next request comes in, request 2, okay, request 2 comes in now. Let's say request 2 came in while we were processing request 1. We only have 1 slot, so it has to wait. It waits basically in queue. This is done. Now request 2 comes in. Now, because we are treating this as your personal engine, we look to see how many messages exist for request 2. Let's say there are 4. What do you think that tells you if there are 4 messages? It tells you that this is probably a continuation of the thread.
Yeah.
We started with 2, now we've got 4.
Yeah.
So what we do then is we process the 4 messages through the template system.
Yeah.
We look to see if the first 2 messages match the input data that's already been cached.
Yeah.
If it does, then all we have to do now is what we call an extend. We extend the cache with the new messages that just came in, right?
Okay.
So this is the original 2. Now we extend it.
Yep.
We process it, and now there's some output. See, what's nice is if request 3 comes in, and then there are, let's say there are 8 messages, I don't know, whatever. We go and we said, well, we currently only have 4 messages in cache. We keep count of that. So this must be the same thread. Continue to extend. And this is giving us tremendous performance because we don't have to process all 8 messages again, decode,
It's only the
tokenize and
new,
decode, only the new ones.
Yeah.
And we continue to extend this.
Okay.
This is where we're getting this sort of massive performance.
Yeah.
Then if a request comes in, but the message count is back down to 2, we say, must be a new thread. So gone, gone, start over.
Got it. Okay.
Right. So we basically I forgot what the word we use, but we basically throw all that out and we start over.
Got it.
Okay.
Okay.
So when you have a deterministic template, which is taking those input messages, processing, remember the template that you saw in the
Yeah.
okay. If it's deterministic, then we know that no matter how many messages are in this, we can guarantee that the previous messages that we saw produce the same input data. It's
Okay.
deterministic.
Okay.
That's beautiful for us because we're always just extending.
Extend. Yeah.
Now, what if we have a non-deterministic template like we do with GPT? So go through it again. R1, 2 messages, run it through the template system. We tokenize, we decode, we put it in here. We're good. Okay. Now, we get request 2. Request 2 comes in. Request 2 comes in. Fine. And this one has message equals 4. Okay. We run it through the template. Let's say that everything was good. No problem, right? It was deterministic at that point.
Yeah.
We just can extend that beyond the next 2.
Okay.
Now, let's say there was a tool call involved in this one. And now we end up with request 3 that, right? Let's say that said do a tool call. Now that comes back, and now we've got, we probably end up having 7 because you have this and the tool call and some other things. And now when we run the template, guess what? Everything is the same here, but these next sets of bytes are different.
The new set.
The new set. So when we take the total set of bytes, we look, is it the same? Is it the same? No, it's only the same up to here.
The extend isn't the same. The
Isn't the
first
same.
extend.
Yeah, let's just say, or some part of the bytes,
Yeah.
but it's either, right? So we could wipe all of it out and redo everything. But what we kind of do in this case is we get rid of these bytes and we have to reprocess
Oh, okay. So from the point that it becomes non-deterministic,
the 5.
you reprocess.
Right.
Reprocess.
So now we got to reprocess basically 5 of those messages, right? And extend this way. That sucks. That hurts.
Yeah.
It makes us go backwards, but we're not doing all 7.
It's
we're
still
only
better.
doing 5.
Yeah.
So this is what happens on the GPT models. The number of messages and if there's tool calls can cause the template to produce different bytes at some point. So this is what we call non-deterministic. At least I call it non-deterministic templates. Now, luckily, the Quen 3 models, and I asked it, was it deterministic? It said yes, right? Are using deterministic. So we never have to sort of roll back and go forward.
Okay, that's interesting.
So if you used an IMC, NC max of 2, now what happens is you get 2 slots, which means that we can process requests in parallel. I'll just put it here for a second. Okay. Now that's cool, right? But as you already saw with the VRAM calculator, that requires more memory.
Yep.
But now what happens is the following. Play this out. Again, I never assume in IMC mode that there are 2 users. I still only assume there's 1. So when we're in IMC mode, I changed it. So this is all about this individual. We could almost change I from incremental to individual. Almost, but it is incremental because you see how we're incrementing it. But it's not designed for 2 people now. So let's say I'm using Kilo.
It was incremental model caching.
Yeah,
right?
we call it incremental message caching.
Okay.
Because we're incrementally adding the changes to this cache.
Got it.
Now, let's say you have this scenario, and I'm using Kilo. So request 1 comes in. It's got 2 messages.
Yep.
And Kilo now decides to send another request in. Doesn't have a system prompt. It's got message 1. So what's going to happen is the first request comes in, it gets slot 0. The next message comes in and we go, oh wait, that's less. It must be a new thread. But
It's really not.
but it's not. So, well, this is what we do. We don't assume it's not, but we look to see, do we have another slot? And the answer is yeah, you got slot 1 and nobody's using it, then go in and start doing that. Now, this is where Kilo kills me. It now also sends request 3 with 1 message. It's just trying to be efficient, right? And I only have 2 slots. So what we're going to do now is request 3 waits in queue, but it can't wait forever. So there's a 30-second wait in here. Essentially, one of these two has to finish now within 30 seconds, or the one that's been running the longest gets cut off and evicted. And we do that just in case you tried to like stop the agent from doing something and you want to start again and you don't want this to have to finish.
Yeah.
Now you can control the timeout, but essentially there's a timeout to get in queue here, and then there's a timeout to get a slot. We use the same sort of 30-second timeout. So you can get maybe a little bit more time. But ideally, once we're here, once we're out of queue and we're waiting out for a slot, the one that doesn't finish first in 30 seconds, we assume that this is stuck, or we assume the user sent in another request because they don't care about the one that's running.
Yeah, it's hanging.
It happens all the time, right? You just say new.
Yep.
So you do have to wait 30 seconds, but 30 seconds is a lot of time for anything to complete. This isn't usually one big task unless the context window starts to get really large or it went crazy. So what happens now? Each slot has its own KV cache.
Okay.
Okay. So this is slot 0's KV cache. Slot 1 will also get its KV cache. So let's just say we don't have this scenario for a second. Let's say request 3 is actually a continuation of request 1. Right? And now let's say that this slot's available. We know that there were 2 messages in here. Yeah. So now what happens? This comes in. We check. Is 4 greater than 2? The slot's not being used anymore, and it's up. Guess what? This must be a continuation of this.
To go to that slot.
So now what we're going to do, actually, before we move it, is we process the template. We check the bytes with this. If they match, then we know for sure
it belongs in that slot. Yeah.
If it doesn't match, then we'll check this one. So we look at a message count first to determine which slots are potentially for this request.
Okay.
Then we'll check what's in the cache against what we just produced. And then 3 can continue here and in this particular extent.
Okay, that's interesting. Yeah, that
Kilo adds the 3rd request element, which is why it's always telling me add 3 slots. And I don't want to add the memory, but if I'm really going to use, I can get away with Kilo with 2 slots because everything runs fast enough. One just stays in queue, and I haven't seen it get evicted. But ideally, if I'm going to use Kilo, I really should set it up for, like we can play with this for us, but ideally, everywhere that you see 2 here should just be 3 because it's really the most efficient way to run that. And when the 3rd request comes in, then what will happen is the slot 3 would be available, and then we can just check sort of stuff, right?
So sort of like they wouldn't finish at the same time. Those slots wouldn't finish at the same time.
They could, which is fine.
But that's why you have that second check.
Yeah, for the bytes. Now, eventually a message comes in that's less. And this is completely different. And then we go back to and treat it like it's completely new, and we start over, right?
Okay.
So
Got it.
if you look at, I like the kilo. I'm going to go back to a 3 here. Let's let that start. So this is what happens at slot management with KV cache. Now, if we go back to, so now we understand that there are model types that affect how we do batch processing.
Mm-hmm.
And then these models may or may not have a deterministic or non-deterministic sort of template situation. So if you see here, partial range delete, right? We're talking about KV cache. After a request completes, the batch engine trims the generated tokens from the KV cache. This removes only the tokens produced during generation, leaving the cache conversation prefix intact. So we're using the KV cache also to produce the output tokens. We can't leave them in the cache,
Yeah.
right? Because that's going to all get redone on the next sort of request. So we rip them out.
Got it.
Normally, if you're not doing any of this, it all gets cleared already.
Hmm.
Hybrid models mix attention layers with recurring layers. So this is where we get into like data sciencey stuff about how these models are sort of wound together and how Llama CPP underneath actually does stuff, right?
Okay.
And attention layers are critical for the model's ability to stay focused. Attention.
Yeah, attention.
Right? So recurring layers stored hidden state that cannot be rewound by partial range delete. So when we're using these hybrid models, it's not that simple to just sort of remove what we just talked about. Okay. A partial delete corrupts the recurrent state, causing decoding errors. So instead, we have to do what's called a snapshot and restore. We take a snapshot of what's in the cache, we process the request, then we restore that back. It's the only way to make sure that we've got it clean. It takes a little bit more time, as opposed to like if we just had a pure dense deterministic model, we can just go ba 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 ba.
Yeah.
Now we know if it's a hybrid model, then we're like, okay, what we're going to do is take a snapshot, right? There's some microseconds involved, process, then restore.
Got it.
It's all happening inside the Llama CPP, so it isn't like death here. Okay,
Got it.
it's like it's not coming back out to CPU, let's say, and doing that. So, oh, actually, no, we are using a bytes buffer and RAM. So this is going, when we say byte buffer and RAM, this is coming out of the GPU. We're storing it in memory. Then it performs a full sequence, right? We store a snapshot. So this is probably taking us a decent number of microseconds, but it's still faster than us reprocessing all the tokens and decoding from scratch, right? So in a standard, we just trim the generated tokens out. In the hybrid, we got to clear and restore the memory copy. And you can see here, it's saying it's going to take somewhere between 10 and 30 milliseconds, but that's still, especially if it's a long context, we're talking, you know, hundreds, if not seconds of time to do that otherwise. But there's no way around it, right? There's no way around it. The moment we say RAM, like we're bummed out.
Got it. Okay. That's interesting.
And when a request matches a partial token prefix, right, and it diverges, then so you have that. So this is why we have to know what type of model we're dealing with, and we're able to sort of figure that out with the GGUF data, right? So is it just an MOE model? Then it's pretty much treated like the dense models, right? See here, if it's a hybrid model, now we've got the problem with the snapshots to make it all work.
Makes sense. Okay. And then it'll rebuild. Okay. I see.
And now when we talk about the message caching, because that's part of the batch processing, the message caching is, you know, gets involved in that. But now we have the system prompt caching. Again, we treat everything as if it's your personal server. So If you have multiple slots and you're using SPC, we're going to do the same thing. We're going to figure out which slot was yours for this last request. And then you can keep that, right? And that's, again, you personally trying to send in multiple requests at the same time. I'm not really caring about multi-user optimization. If you're going to use multi-user, you can't use any of the caching here. But you're not going to get any level of performance. At that point, go VLLM, go SGLang. That's what they're designed for, right? Like for a prediction guard to have a bunch of users slamming on it with some level of optimizations.
Yeah.
This has been designed so we can keep our heads straight to give you, the individual person, the highest level of performance gains on your machine by basically treating the cache optimizations as single person, and all requests are coming from a single person.
Got it.
Right?
Okay.
Or like a single agent, a single app that's doing things.
Okay.
That's a decision I made.
So it could still be, let's say, I guess, multi-machine. Like when you have both Mac Studios running, it's but it's still.
I mean, look, I could put up a small server with 5 slots if I had the memory with 5 team members, and we should figure out which slot is yours
Yeah.
for a given thing. But that's not what I'm building it for. If
Exactly.
you've got 3 slots, it's because your agent is trying to send in 3 requests, not because you want Larry, Mo, and Henry to like be using it, right?
Got it. Okay.
So
That makes sense.
if I switch over to this now, here's kilo code. Okay, again, there's going to be 3 requests. So let's clear this. Let me just say, tell me, watch this, just even this simple one here. Tell me when you are ready to handle requests. I love this interface better than the client, but this also requires the model to be very good at real tool calling. Like you can't mess up.
Yeah.
This Q6 model has been that. But remember now what I'm doing from a calculator perspective, right? We're now using this model in the 6 with a 96 and an F16 and 3 slots. So,
97. Yeah.
I mean, I'm close to 128 gig. Like all that's not going to fit in the GPU. There's going to be problems. I think I finally got all that loaded in memory. So sometimes I just look for in. So there's my in request, and I think it finished. Okay, I'm ready to handle requests. So even if I just do this, right, let this finish. Okay, look at these logs. I'm using Kilo, which tends to use 3 requests at a time. I am also using the GPT model, which is a dense but non-deterministic template. And I am using IMC, right?
Yep.
So now I'll start a new task. So I can ask it sort of the same things, right? How many lines of Go code are in this project? Now I'm using the GPT 120B model because it just has been the absolute best with the tool calling.
Okay.
We could try the Q6 again after this. Let's see how fast this runs with the GPT and if there's any inconsistencies there with it.
Surprised your fan hasn't kicked on.
I am too, bro. I killed the fan. gonna run it anyway. Those temperatures are at like 200.
Mm-hmm.
Now, you can already kind of feel that it's a little slower,
Yeah.
right? And it's because, in all honesty, I'm looking for the end sequence. It's because it's trying to do too much for me on this machine. It's thinking it's talking to cloud and it can like throw 3 at it. And there's no way to tell Kilo, don't try to be like faster than me, like just,
Okay.
right? But now that we need all this extra memory and all this extra processing, and so it gave me an answer, right? It came back. That was kind of cool. What's nice about here is I can ask a follow-up question here.
Oh, okay.
Like,
And that's just because of how Kilo
yeah,
works.
which file did you see had the most lines of Go code? Like here I can ask the follow-up question, at least I've been able to.
I do like the UI better.
Okay, so here's what the logs show. Your model is actually an MOE, not dense. I didn't realize that.
Type MOE.
See, it definitely sent in a second request for there.
Request to save 21 seconds. Okay.
And I'm getting better TPS, right? This model
Yeah.
just runs a little bit faster here. And I'm using 3 because I know what's going to happen, right? Where was my question here? See, how beautiful was that? I was able to ask a follow-up question, right?
Yeah, that behaved nice.
Now, you want to see the whole thing? Okay, so let's just say we stayed here for a second,
Yeah.
okay? Now, that's the GPT model. It works really, really well. Let's go and use the Kilo version, which is going to give us 3 as well, okay? Just like keeping this clean. Okay, so let's go back and ask it the same questions. How many lines of Go code are in this project? This is what I do all freaking day, trying to get these things to work right. So now we're using the Kilo. It's got to load that up. So I don't care about how long that one takes.
So was GPT a bigger model than this one?
It's the open source version from
Oh, so it's the 28.
from OpenAI, right? But I'm using the 120B. The 20B
Oh,
would never
okay.
be good enough.
Okay, yeah, I'm thinking 20B.
But it handles tool calling really, really well. Like I don't have to do anything. I don't have to use any grammars or anything. But so let's look at the GPT model while that runs for a second. This is the GPT model, right? So if I go back to this VM calculator, and I'm using 128 on that, you can see that needed the same sort of 94.
I think it's a little less.
A little bit maybe. On this one, I have a much larger context window than I can use on the other one too. Here. But let's just see if it finishes without any errors, because that means the tool calling, the native tool calling is working, right?
Yeah.
And it had to load this model up first. So like this taking as long as it did, but I feel like it's also a little bit more inefficient because what drives me crazy is I feel like it could have given me the answer already, but it's
Yeah,
running.
it's making, oh, this was wrong,
You
wrong,
see
wrong.
how it's like sort of, so the model isn't, I don't think for this particular agent working as well as GPT did.
Yeah.
And that's the other thing, right? So now that we've got this, right, which file did you discover had the most lines of Go code? The fact that it's working without failure, which eventually it will fail, is amazing
Yep.
because I couldn't get that with the other Quen model. But I still feel like the GPT model works better. Now, you might say, Bill, why aren't you using the GPT model with Klein? Because it won't listen
Hmm.
and it wants to use native tool calling. And this could be just, now this to me could be a tool call error,
Yep.
right? Though here's the tool call that it gave it, but it could very much be that it wasn't formed right. Kilo's really like particular with this. But it's not as efficient as the GPT one. But the GPT one, no matter what Klein tells it, it wants to use a regular tool call. And Klein just won't support it with the GPT OSS model.
Hmm.
Like
Okay.
it knows the GPT models do this, but if you're using the big cloud ones, it says, okay, I'll use it, but
It won't
I
do it.
can't get it to use it. So it all
Oh,
fails
okay.
miserably in Klein. But you see how sort of long and inefficient this
It's just
is.
iterating more,
Yeah,
like it's going in a
you
circle
see?
basically to do the same thing.
And it's just a bummer, right? But if I stick with the GPT Kilo, so I
Yep.
get that, then I get a decent experience here. Summary of this file. And I do have this also using,
Oh,
I don't remember. It's been a while since I have the MCP server working here too, but I don't remember how to get to it now. Yeah, click here. Oh, where did it go? Didn't need that. I don't know what happened. I must have to fix that, but it could use the same cronk MCP here too. I don't know where it went though. Interesting. Anyway, you see how nice the GPT model's working on the
yeah.
3? I like Kilo better in terms of the UI and everything, but I just feel like the next model has been fairly better overall on the client side, but then I don't sort of see it here.
Hmm.
And the GPT isn't running as efficient as it could because of the non-deterministic templating.
Yeah. But that's
And
just
Klein
something
always feels like it finishes faster.
Klein
So
does.
yeah,
Uh,
so and that's my other problem here, right? Let me know when you are ready. I do allow both models to be, I should just disconnect, drop the connection. Oh, I can do this, I forgot. So we added this now too. Out of memory in the server. Get my
nice.
memory back. All right,
Nice.
yeah. totally important to be able to do that. So now that should free up some memory because we evicted that out of the. So I'm starting a whole blog post series now on all of this stuff, starting with the model selection and then going into we'll go into, I don't know, whatever I think is next, IMC and things like that.
I think that'll be cool. I mean, there's a lot. There's a lot here.
I don't know.
There's
Me,
like,
I'm trying to keep my head around it all. But this is all I care about. So remember the same question that I asked Kilo, right, with the GPT model.
yep.
You'll watch. It's just more efficient somehow. And I don't know if I don't know what it has to do with, but I have not found another model outside of that GPT 120 that does the tool calling as efficient and it's faster, right? So we saw this working, but in Kilo, but I think Kilo really needs the multiple requests. Boom.
Yeah, that
So
was
it's like,
faster.
how do I not use Klein?
That
But
was like significantly
but
faster.
now I can't ask a follow-up question. Let me see. Can you go into more details about the input? So watch what happens. This is the thing. It's like I want to blend these two agents together, and
Huh.
that's what kills me here, bro. That it gets into this mode where it's sending not even sending my question. Look,
Does it do that too with like hosted models?
I don't know, but look, it's not even sending my question.
Not.
This is what it just sent in. Look. And if I use the new task, can you explore? Can you give me more details about the? And nobody over there will help me. So like that really bums me out. Look, so that's the question. Can you give me more details? No. What did it send?
Attempt to
Yes, it sent done.
yeah.
See that shit?
How does that work though?
I don't know. From my perspective, this is a bug. Unless it gets into a mode where it allows you, once the task is complete, you're done, right? You're done. And so now, I could do this. There's no way that I can see to like link the history, right? So can you look at the last, what do they call it? Last task. The last task and view the output, view the final response. I have questions. Like, this is something I could do in AMP, right? But I don't think it has the context for this. So this is what kills me. Like, I can use it for single tasks.
One thing at a time, but
One thing at a time.
how often do you really do that though?
Like in real world life where you have follow-ups and stuff, no.
Oh.
And then the Kilo works, but it's not as efficient with either model. And so, and because it's using 3 requests, requires the more, you see where I'm at?
Yeah, it's like you have to sacrifice
I
one
have
or
to
the other.
sacrifice something. See, it doesn't even have access to my thing, right? So here's the history. So now I can give it this output, but I didn't tell it. Let's see what happens. Want to know more about the input, output. What was it? Input and output handling. See, so that's working for me. I had to copy that in. And now I'm starting a new task where I forgot to ask it the question. But, and that's like, okay, but it's just silly that I have to do that. And I've tried all the different settings. I don't know if it's a to-do problem because they like these to-do lists to keep the model focused. And I appreciate that, right? Because as
Okay.
your context windows get large, the model can lose focus. And so
Yep.
the idea of the to-do list is
Keeps
to
it,
keep that.
yeah, keeps it structured.
Now look, that just worked. But now I got to copy this. Actually, first time I've even tried this. If I copy this but whatever, like how much better is this working though?
Yeah. I mean, it is a lot faster than
Yeah,
Kilo. It is a lot faster, but
yeah.
it's also like you kind of need that conversational aspect of it
It would
to
be nice
do
to
anything
have
real.
it. So, but I'm not looking to do, again, I have a small context window because
Yeah.
but still, dude, look where we're at right now with this. So,
It's still really cool.
okay, so made these two changes. Let's just make sure they're in here. Okay. So I'm going to start blogging about all this stuff and we'll have more conversations. But what I want to start doing, today was more of an exploration and there's so much to even cover, right?
Yeah.
But Kilo settings. What I want to do is start building something with, and I think one of the things we could build, I mean, you should think about it a little bit, but
Mm-hmm.
we had started that project a billion years ago to process all the video,
Yes.
right? And
That's
we
how it
were
started.
using the model server, Llama, and all that. And right, it
Yep.
would be good if we could just build a Go program that does it all without needing the model server, right? I
Okay.
mean, that's the power of Kronk.
Yeah.
And that will also let us dog food the SDK a little bit more.
Okay. I see. So using Kronk to do the video processing.
So I think next month we'll start that work. On Thursday, we'll come back and again explore the project and go deeper into some things. But I think when I get back from Brazil and Virginia, then we start to build that thing as a real product. And
That would be cool. And then I'm sure we'll find a lot of things too, of places to improve and
I'll have the cluster up and running by then. We'll have more power and we can like SSH into that and do more.
that would be cool too to learn how to sort of work on a cluster like that,
Yeah, I gotta
like a
learn
home
this.
lab basically.
So
That'll be cool.
we're there. All right, everybody. Thanks for hanging out. I think it was a good session, and we'll share this, and there'll be more documentation for Klein as we go. All right, everybody. Thanks.